Welcome to The Explainer. Today, we're going to pull back the curtain on a hidden science, an invisible shield that literally keeps our modern world from crumbling into a pile of rust. We're talking about everything from massive ships to the pipes buried right under our feet.
Okay, so let's just jump right in with a big question. Have you ever really thought about all the steel out there? The bridges we drive on, the pipelines that deliver our energy, the ships that cross the ocean? What stops all of that from just, well, falling apart? The answer, as it turns out, is a seriously cool piece of engineering. So to really get the solution, we've got to understand the problem first. And the problem, our villain in this story, is corrosion. It's quiet, it's natural, and believe me, it is absolutely relentless. You see, corrosion isn't just stuff getting old and worn out. Nope, it's a full-on electrochemical process. Think of it like this. Nature is constantly trying to hit the undo button on all the work we did to make strong, refined metals. It's always attacking our infrastructure, trying to turn that shiny, solid steel back into what it started as. You know, that brittle, flaky stuff we call rust. But hey, where there's a villain, you know there's got to be a hero, right? So let's bring in the hero of our story, a really powerful and ingenious scientific principle called cathodic protection. So what is this stuff really? At its heart, cathodic protection is a brilliant trick. In any corrosive situation, you've got two parts, an attacker, called the anode, and a victim, the cathode. What this technique does is it basically flips a switch and forces the metal we want to protect to become the cathode. And by doing that, we make it totally immune to the attack. It's amazing.
Let's break down how this magic trick works. It's actually pretty simple in 3 steps. First, you've got your steel structure. By itself, it's vulnerable. It's the natural anode. Second, you hook it up to a special system that's designed to basically yell, "Hey, over here," to the corrosion. And finally, that redirects the whole attack, turning our original structure into the safe, protected cathode. We're literally tricking nature to protect our own stuff. All right, so how does our hero actually fight this fight? Well, it has 2 main strategies. Let's start with the first one, which I love to call the bodyguard method. The whole idea behind the bodyguard method is just fascinating. It turns out that some metals are just way more eager to corrode than others. They're just more electrochemically active. So what we can do is take a more active metal like zinc or aluminum and put it next to our less active steel. We're basically giving corrosion a much more tempting target to go after. So here's how it plays out in the real world. You take a block of that more active metal, that's our bodyguard, and you physically attach it right to the steel structure. Immediately, all the corrosive forces in the environment are drawn to the bodyguard. It starts to corrode away on purpose. It literally sacrifices itself. And in the process, the main structure is left completely safe and sound. It's a really simple, elegant, and totally self-powered system. Okay, so that's the bodyguard. But what if you need something a little more heavy-duty? Well, let's talk about the second technique. If the first one is a bodyguard, this one is much more like an invisible force field. It's called impressed current cathodic protection. And the huge difference is right there in the name, impressed current. Instead of just relying on the natural chemistry of metals, this method gets proactive. It uses an outside power source, like a battery or a rectifier, to generate a constant, protective flow of electricity. It's like wrapping the whole structure in an energy shield. This slide shows you the whole setup perfectly. You've got a DC power supply that pushes current out through a special, long-lasting anode. That current then flows through whatever is around the structure, could be soil, could be water, and onto the pipeline or tank we're trying to protect. That flow of energy creates the protective force field, forcing our structure to be the cathode, which means it can't corrode. It's a complete electrical circuit built for defense. So, we've got 2 awesome methods, right? The self-powered bodyguard and the active force field. But how do engineers decide which shield to use for which job? Well, that's the next big question. And this table just lays it out beautifully. The sacrificial anode system, it's self-powered, which makes it perfect for smaller, more isolated things, like a ship's hull, or maybe even your water heater at home. The main thing you have to do is just replace that anode every few years once it's been used up. On the other hand, the impressed current system needs power and monitoring, but man, it can protect huge, sprawling structures, like a pipeline that runs across the entire country for decades and decades. And that really brings us to the crucial point here. It's not about which method is better than the other, it's all about which one is fitter for the task at hand. Engineers have to look at everything, the size of the structure, how long it needs to last, the environment it's in, to pick the absolute perfect invisible shield for the job. So when you boil it all down, that's the big takeaway.
Whether we're using a self-sacrificing bodyguard or an electric force field, the end goal is exactly the same. We're using some really clever electrochemistry to outsmart a relentless force of nature, and in doing so, we're preserving the critical infrastructure that our entire world depends on.
So, now you're in on the secret. Next time you see a ship in a harbor, look really close at the hull for those little blocks of metal welded on. When you drive over a huge steel bridge, just think about that invisible current that might be flowing around it, keeping it strong. Now that you know what to look for, what other invisible protectors are you going to start noticing out in the world?